We are now going to work on this question, but first pause the video and try the question. Two dice are thrown and the numbers A and B shown on each die are noted. The score X from the throw is defined by X. So if A is equal to B, you're going to take A plus B, and if A is not equal to B, you're going to take the absolute value of A minus B. You're asked to tabulate the probability distribution of X and calculate expectation of X and variance of X. The first thing we're going to do is to draw the probability distribution table. Now, for us to be able to draw the probability distribution table is we need to have what the values of X and its corresponding probabilities. So we do not have these values right now. So how are we going to find these values? We are going to do a possibility diagram or a probability diagram, which is similar to a Cartesian plane. This is the possibility diagram where A is represented on the x-axis and B is represented on the y-axis. Or A could have been on the y, B could have been on the x-axis. A and B are dice, which means that they can take values 1 to 6. X says if A is equal to B, we're going to take A plus B, and if A is not equal to B, we're going to take the absolute value of A minus B. Now, before we tackle the question, let's see what is absolute value. Absolute value of a number, suppose X, is the numerical value of X and is denoted by modulus. So modulus of X. For example, if I have the modulus of 3, it's going to be the numerical value, which is 3. And if I have the modulus of negative 3, it's going to be the numerical value 3. It's basically you're considering only the number. So if I have the absolute value of negative 5, it's simply going to be 5. So we're going to use absolute value in this question. So it says that if A is equal to B, we're going to take A plus B. So when do we have such cases when A is equal to B? So we can see along the diagonal when A is equal to 1, B is equal to 1, A is equal to 2, B is equal to 2, and it goes on up till A is equal to 6, B is equal to 6. So whenever we have A equals B, we're going to add, which means that 1 plus 1, we're going to have 2. And then 2 plus 2, we're going to have 4. 3 plus 3, we're going to have 6. And then 4 plus 4, we're going to have 8. 5 plus 5, we're going to have 10. And then 6 plus 6, we're going to have 12. That's the only cases where we have A is equal to B. Now we're going to fill in the rest of the values where A is not equal to B. So if A is not equal to B, we are going to take the absolute value of A minus B. So if A is 1, B is 2, we take 1 minus 2. So A is equal to 1, B is equal to 2, A is not equal to B. What are we going to do? We're going to take 1 minus 2 and then we take the modulus, which is the modulus of minus 1, which is 1. So here we have it, 1. Now 1 and 3, it's going to be 2. 1 and 4, it's going to be 3. 1 and 5, it's going to be 4. 1 and 6 is going to be 5. I'll let you complete the table and then we'll get back to it. Now that we have completed the possibility diagram, we can see that X can take different values. That is, X can take 1, 2, 3, 4, 5, 6, 8, 10 and 12. Once we know the values of X, we can find the probabilities for each value. So we can draw our probability distribution. So we're going to fill in the values of X where we've seen that it can take 1, 2, 3, 4, 5, 6, 8, 10 and 12. Now, how are we going to find the probability of each, how many times a particular value is occurring. We know that the total number of values that we have is what? 36. So out of the 36, how many 1 do we have? How many 2 do we have? It's basically we are finding the probability of a particular number. What is the formula for finding probability? Number of favorable outcome over the total number of outcome. Favorable outcome is the value that we want. So if we want number 1, we're going to count how many ones we have. So we can see that 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Probability of x is equal to 1 is going to be 10 over 36. So we're going to do the same for the other values of x. So what is the probability of getting 2? So we're going to count how many 2's do we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 over 36. You do the same way for the other values. Okay, so pause this video, complete the table, and then we're going to continue. So there we have it, the probability distribution table with the completed probabilities. Please check your answers. Now from there we are going to check whether x is well defined. We're simply going to add all the probabilities. If it gives us 1, it means that x is well defined. Once we have the table, once we have the probability table, we are going to calculate the expectation of x. Now we've already done this. So expectation, again we're going to use the formula, the sum of all values of x. We take x, we multiply by the probability. So the expectation, if you work the question, you should get 28 over 9. The variance, first you need to find what first? You need to find the expectation of x square minus the mean mu to the square. The answer for the expectation of x square is 287 over 18. Then the variance is 287 divided by 18. You minus the mean, which is 28 over 9 to the square. You should get 643 over. The expectation of x is going to be 1 multiplied by 10 over 36 plus 2 multiplied by 9 over 36 plus you go up till 12 multiplied by 1 over 36. Use your calculator to get the answer. Similarly, for the expectation of x square, you have to remember that to be able to find the variance of x, we need to find the expectation of x square first. 1 square multiplied by 10 over 36 plus 2 square multiplied by 9 over 36 plus it goes on till 12 squares multiplied by 1 over 36. You get the answer. Expectation of x square minus mean the square. Okay.